Welcome to another T-Rex Talk. We're outside today and I want to be talking about GPS devices, but also how GPS actually works for a number of reasons. And part of it is a few weeks ago I was posting on Instagram and posting about some Garmin devices, specifically some Garmin watches, and people had a number of different opinions on the practical value and weaknesses of GPS, some of which were rather ill-founded, which I'll get to in a little bit. So I think that all of us should have a pretty good understanding of how GPS works, strengths, weaknesses, and the practical uses of specific devices, and an understanding of how far you can actually trust GPS, which means we're going to get to talk about the weaknesses of the system. We're going to talk about how easy it is to jam GPS, how easy it is to spoof GPS. I'll tell you right now, spoiler alert, it's pretty easy. I myself was able to spoof some GPS devices, which I did in a completely legal way. Didn't cause any interference for anybody. I'll just say that right up front. But I'll talk a little bit more about that later on. So talking about GPS and how it works. So there are at any given time just over 30 GPS satellites above the Earth, and they last about 10 years. After about 10 years, they fall out of orbit and they have to send new ones up. First GPS satellite was launched in 1978, and where those GPS satellites sit is about 12,500 miles away from the Earth itself. So that is very far away. The Earth's diameter is 8,000 miles, so imagine that there is room for like 1.5 Earths in between each of these satellites and the surface of the planet that we are walking on right now. Because those satellites are so far away, those 30 satellites can see all of the Earth. And from anywhere on Earth, you can see an awful lot of those 30 satellites. And they are constantly broadcasting signals. And the most important signal that they send is a time signature, which is super accurate. They have to have super accurate clocks, accurate to about 30 nanoseconds in order for GPS to be as accurate as it is today, which is basically around 6 feet. You should be able to get your location to within a radius, or actually I think it's a diameter of about 6 feet using off-the-shelf commercial technology at any given time. You can actually get much more accurate than that if you leave a GPS device in one spot for a very long time, record data for hours. You will see a circle of errors that really centers on your position, then you can get your position much more accurately. And GPS, the US GPS system is not the only one that exists. Europe has Galileo, Russia has GLONASS, China has Beidou and AZSS. There's quite a few other sort of competitors out there that use really similar technologies just in a different way for other countries. And a lot of those are open to the public. You can actually use the Galileo and GLONASS satellites to get your GPS signal a little more accurate, a little more quickly, if your GPS receiver can see those signals. But mostly we're going to talk about the American system. And that American GPS system has two streams of data. One that is open to civilians, called SPS, and one that is encrypted for military, called PPS. And when I was a kid, the SPS signal that was available to us civilians had something on it called selective ability. It was actually a downgraded signal. On purpose, they introduced a significant amount of errors to those time clocks. So they were not within 30 nanoseconds of each other. I don't even know what the actual time offset was, but it was enough to introduce hundreds of feet of errors. So when I was a kid, GPS technology that was available to civilians didn't let you pinpoint your area on the Earth very, very precisely at all. But in the year 2000, they removed that selective ability so that civilian receivers now had the same time signal, the same accuracy as the military units, and that was all open and in the clear. Now, the other thing that happened around the year 2000 was that GPS receivers got a lot cheaper. The hardware and the software was a lot more available and started to get used in a lot more things. And all the receiver really has to do is listen for that time signature that is coming down from the satellites. And it has to have a pretty well-tuned antenna because the signal is extremely weak. The satellites that are, again, over 12,000 miles away, they'll never be closer than 12,550 miles. But the ones that you see closer to the horizon are a lot further away than that. And none of those satellites have a transmitter that is more than 50 watts, which is kind of amazing because there are trucks on the road with CB radios putting out more than 50 watts. So the antenna receiving that signal has to be very sensitive, but everything after that is extremely simple. The math is really straightforward. And I have for years and years thought that GPS satellites and GPS receivers worked using triangulation. Turns out I was wrong. Triangulation works using angles. GPS works using trilateration. That means it uses the latency to figure it out. By listening to those time stamps from the different satellites, you're able to figure out your exact distance from each one, which means once you see 4 satellites, you can figure out your exact position in 3D space. It's relatively complicated because the Earth is round and the satellites exist in 3-dimensional space, but the math is actually not that complicated. And so the ability to have really cheap GPS receivers and extremely accurate coordinates made a new type of product viable. A whole bunch of companies started making GPS navigation devices, things that were specifically going to give you turn-by-turn directions on roads. Garmin, Magellan, TomTom, a whole bunch of people were developing these products, and they were extremely popular right up until, well, roughly about the same time that the iPhone and Google Maps sort of made them obsolete. But it didn't stop the adoption of GPS receivers. In fact, those have gotten only smaller and cheaper and more accurate and in more things. There's an awful lot of modern technology that uses GPS receivers for things besides navigation. Things like getting a really accurate clock signature. A lot of radio technology uses the GPS clock for its synchronization because it's an extremely accurate thing that you can get for devices that are going to be very, very far apart from each other. And in regular conversation, the term GPS has gotten a little bit confused as well. People use it for all kinds of geolocation data, all kinds of tracking, and all kinds of surveillance, to the point that when I post pictures of a Garmin GPS on Instagram, people post, "Now the government can track you," which is, I mean, let's be honest. It's a really dumb thing for you to post on the internet, specifically when you are using a literal surveillance device to type in that message and then post it to Instagram, which is owned by Meta, a company that collaborates with the government and collects data for a whole bunch of people that are doing mass surveillance. I'm not saying that the guy who wrote that message is too paranoid. In fact, he's probably not paranoid enough, because there's all kinds of location tracking that is going on and way more location surveillance and data mining than you are probably aware of. Yes, your phone has a GPS receiver in it, which it uses to determine its location under a number of circumstances, but it can also get its location data from cell towers. Cell towers can see where the phone is at almost all times, and if your phone is connected to the internet in any way, it's communicating with Google servers. Even if you have an iPhone, your iPhone talks to Google servers sometimes more often than an Android phone, which means that Google and Apple and oftentimes Amazon knows the physical location of your phone. And Google also knows the physical location of most of the Wi-Fi access points on the entire planet, which means that even if you've turned your GPS off and you're not connected to any cell phone towers, if you're connected to one of those Wi-Fi adapters, Google has a really good idea of where you are. And new technology is often very location-based. So Elon Musk's new satellite communication technology, Starlink, is extremely cool, mostly because Starlink is a two-way satellite system. So you get your data from space, and Elon Musk gets data from you, and they have to know your location for this system to work. Starlink data communication cannot work if the Starlink satellites don't know where your physical dish is. So more and more of these new systems that are coming online are more and more dependent on user data. And your user location data is very valuable and probably goes a lot further than you think it does. If you Google fog reveal, you will learn a lot more about how easy your personal location data is to buy or get access to, and how widely it is already being used in ways that you probably didn't fully comprehend. So again, that guy that posted that comment, not too paranoid, but also doesn't really understand how GPS devices, specifically old school GPS receivers, work. And if he did, he would be on board with having an old school GPS receiver like the ones that I'm recommending that you have. I really like the idea of going back to those simple one-way satellite communication devices. A satellite receiver, like say, just for reference, a Garmin eTrex device, something that listens to GPS signals, doesn't transmit anything, and already has map data stored on it. It's old, in some ways it's kind of clunky, but it is extremely useful. For many, many years, I have been using Garmin handheld devices. I've used them in cars, I've used them off-road, I've used them on-road, and recently I have been tinkering with some of the Garmin watches. And I think that all these devices have a lot of practical uses. They have upsides, they have downsides, but again, having a device that is able to tell you where you are on the planet without communicating stuff back to Google, Apple, or Amazon for clarification is a really handy thing. Not only because, surveillance, but also because in a disastrous situation where cell phone towers are down or where the internet is out or something like that, being able to actually get your location is important. Obviously, if I were a land navigation guru, I would be really, really good at terrain association. That's kind of like the holy grail skill level, where you're able to look at a map and look at the ground in front of you and know exactly where you are. Now, unfortunately, here in Tennessee, that's actually super difficult. Right now, I am in underbrush, which means I can't actually see any terrain. All I can see is leaves. And so even though I have a map of this location that has topographical data and hillshade data and is very, very useful for navigation, and I have a really good idea of what the terrain is like around me, I don't know exactly where around me actually is. And that's where a GPS device, even if I'm only using it to get my location and not necessarily to look at map data, is super useful. That's where a GPS watch has a very interesting value add for me. A handheld device that gives me mapping data and my location, well, that's just better still. There's a number of places here in Tennessee where even if I were an incredibly accomplished land navigation guru, I would still really welcome the ability to find my exact coordinates using a device. Now, that being said, it isn't something that you should necessarily trust completely. There's a lot of weaknesses to GPS in general. The entire system is pretty fragile, and so even though I love my Garmin eTrex device, and I basically have it with me at all times just in case as a backup, it isn't infallible. GPS is really easy to jam, and as I discovered a couple of nights ago, GPS is extremely easy to spoof. Let's talk about jamming first. So GPS jamming is becoming increasingly popular exactly at the same rate that drones are becoming increasingly popular. Most cheap off-the-shelf drones don't fly very well without GPS, and jamming the super weak GPS signals that are coming from 12,000 miles away, that's way easier than jamming the control signals that the drones and the drone operators are using. So GPS jamming for the purpose of discouraging drone use, extremely widespread, and it's also extremely easy. Those GPS signals are so incredibly weak that they can be overpowered by accident. There was an incident that happened a few years ago. It was a port in California. The entire port had zero GPS capability. And they finally tracked the cause down to a TV antenna, which had a built-in amplifier that was malfunctioning. And even though this thing was inside of a metal locker, it still completely wiped out the GPS signal for over a kilometer in all directions. And if you want to see some of the places where GPS jamming is happening, probably on purpose, I recommend that you go check out gpsjam.org. I'll have a link to it in the show notes, but it is actually a real-time map that shows you places where airplanes cannot get a GPS fix. And when you look at the map, you look at specific areas around, say, Turkey or Moscow, or maybe some other places in the Middle East, you will notice that GPS jamming is happening in places where you would probably expect to see it. And because the map data is derived from airplane flights, there are chunks of missing data in the middle of the ocean or places like Ukraine, which is currently a no-fly list. But I would guess there's some pretty significant GPS jamming happening in Ukraine right now. Then there is GPS spoofing, which is a lot more insidious. If your GPS is jammed, you just will not be able to get a signal. You will know that you cannot trust your GPS to give you a location because it just plain won't give you a location. GPS spoofing is fooling the GPS device to give you a location that is incorrect. And this is also not super difficult to do. Years ago, when Pokemon Go was a significant phenomenon, there were people who were using GPS spoofing to make their phones believe that they were in places where rare Pokemons had been observed, even though they were physically not there. And the other night, I got my Hack RF Portapack device, and I programmed that to send a spoof GPS signal. And I tricked all of the GPS devices that I had in the house and convinced them that they were actually in different parts of the world with surprisingly little work. Now, I did a really super simple thing. I could not convince my telephones that they were in a different place because they were getting enough signals from cell phone towers and from non-GPS navigation satellites that they were just confused. They could not give me an accurate location because they were hearing different things from the real GLONASS satellites and my fake GPS satellites. If I had a more sophisticated setup where I could spoof multiple communication channels at the same time, I would have had more luck. And there's also some evidence of people using GPS spoofing technology to capture military drones. Iran stole one of our military drones this way about 10 years ago, and they probably did not spoof that encrypted military GPS stream. Probably what they did was jammed the military signal, which would have forced the drone to switch over to that civilian open frequency, which they were easily able to spoof and then trick the drone into landing into the wrong location, an Iranian airbase rather than an American one. So I think it is really important that we understand the various weaknesses of GPS. In certain places, you're probably not going to have an accurate signal. In certain scenarios, you probably won't be able to trust the signal that you get. But for the most part, it is a very robust system that I much prefer relying on than, say, Google, Apple, or Amazon. Now, you might be curious about the rest of the system. The satellites that are 12,000 plus miles above the surface of the Earth last for about 10 years. So you would assume that in a gigantic, cataclysmic World War III type of event, they might continue to give you good and trustworthy signals for at least part of a decade. The problem is that the GPS system requires some pretty significant updates from ground control. The United States has a whole bunch of different ground control stations that talk to those satellites and correct for things like drift of the satellites themselves, drift of the clocks, and even some changing atmospheric conditions. Generally speaking, the constellation of GPS satellites gets some level of correction every single day. So if all of those ground stations were wiped out, the GPS system would not be trustworthy within, I'd say probably about a week. The good news is that the military is completely reliant on that GPS constellation for a whole bunch of different things. They're not totally reliant on it for everything, but it would be definitely in their best interest to try to keep it up and running and accurate for as long as possible. So that's not really an end case that I'm specifically planning around, except that I'm trying to always have a map and a compass as a backup. Obviously, I've talked about different map technologies, and you guys probably know that I have good offline maps on my phone, and generally speaking, I have internet that lets me get to online maps on my phone, but a GPS device is an extremely useful backup, and there's a lot of different situations in which it would be the superior alternative. So I would highly recommend that you consider what sort of handheld GPS devices would be useful for the kind of scenarios that you are thinking about, the kind of environment that you live in. It's definitely a great backup capability, since it is a lot easier to just buy something like, and I guess I should probably link to it in the show notes, the Garmin eTrex 32, because it's extremely small and affordable, runs on AA batteries, and comes out of the box with topographical maps for the entire, at least the continental US. Possibly North America. And it has a micro SD card if you want to add any extra map information to it. So thanks for listening to this podcast, a brief conversation about thoughts about GPS. Some of this material should definitely be inside of a YouTube video, because a lot of the stuff that I was trying to describe verbally would work an awful lot better as a video with some animations and some clearer visual examples. So keep an eye out for our YouTube channel. We'll probably be doing that in the next, I'm not sure how long.